Basically, yes, thank you very much. My name is Andrew Przytuła, and I'm a performance engineer in Performetriks. And on this panel, I would like to talk why performance matters. During this event, we heard a couple of very good questions about the performance. So I think this panel will give you more knowledge about why performance matters. So basically, why performance matters is a big question. And you know that customers have not enough time. They are in the rush, trying to do more in the last minute. It was a very good research from other team group that pointed out that having only 1 second delay, which is something like blink of the eye, the page views are going down by 10%. The customer satisfaction is going down by 15%. And even conversation is going down dramatically by 5%. But most importantly, the company revenue for 1 second delay is going down by more than 2%. So that's a lot of money companies are losing just because of the performance problems. On the other hand, Netflix also experienced that when they had enabled the compression in their network, they realized a fantastic reduce of their network bandwidth bill. Imagine there is a lot of streaming going on in Netflix, and Netflix saved a very big amount of money just after improving the compression for their network. So performance absolutely matters. Keep that in mind when you do your next performance engineering project so that you do not experience that kind of issues. Performetriks is a very experienced performance engineering player. We mainly work and support banking financial service providers around the world. We have done some statistics where we identify performance glitches and performance challenges, and we came to conclusion that only 10% of all our performance issues were identified in the infrastructure layer. And they rarely have been solved by, for example, adding more hardware, more CPU, or more memory. The biggest proportion nowadays is really based on design, coding, and configuration. And there are some more challenging performance issues. Problem with that kind of performance issues are that they are typically detected late in the life cycle, and they are very expensive and difficult to solve. Only when you have an advanced performance engineering concept and advanced tooling in place, then you can identify these issues before deploying new release to the production. So keep in mind that a late detection of the performance problems introduced in the construction phase make performance issues very expensive to fix. The big question is, what is the high performance core banking? And based on our experience, there are basic credential or let's say ingredients. You need to have non-functional requirements and performance quality gates in place so that the teams are understanding what kind of KPIs, what kind of performance requirements are needed to be fulfilled. You need to have some visualization that everyone is aware what is the current state, what is the target, and eventually also what kind of gaps you have. And last, even a feedback loop is needed. Imagine that you identify performance issues on production. You need to involve your development teams so they can also improve the next release. To avoid that, this won't be an ongoing issue and have a high impact on your business, you need to make sure that you make performance everyone's daily job, so that entire organization is working and improving the overall end user experience. As mentioned before, meaningful non-functional requirements are absolutely important. The challenge is always that non-functional requirements are difficult to catch. The business teams know exactly what kind of features they need to implement. For instance, new online banking. They know exactly what features are needed, but in many cases, they completely neglect the performance non-functional requirements. And they do not specify, for example, how many users need to be supported, or what are the expected overall response times, what is the growth ratio, and also what is, for example, the expected throughput. So avoid that you neglected non-functional requirements and try to start early as part of your design phase by building very meaningful non-functional requirements. And also it's very important that you created high quality software and you do not spend too much money on fixing and improving such very difficult to catch performance glitches late in the life cycle. The second topic is about the quality gates. It's also a very important element of your development lifecycle. Ideally, nowadays, performance engineering, performance testing is done in the highly automated fashion. You set up automated performance quality gates, you have early performance feedback, you catch performance challenges early in your lifecycle. And you can involve your developers to fix these issues also early before they build more and more code on top of it. And make sure that the resolution of the problems and that can make the resolution of the problems even more complex. So keep in mind that teams absolutely achieve more if they know what kind of performance requirements are needed to be achieved. The third topic we want to share with you is one of the most important elements. It is the way we visualize the actual state of performance, reliability, and availability of our critical services. We have learned this lesson from one of our major banks we are doing business with. We have started implementing big monitoring screen showing the performance health of their most important applications. And that was a big success story for them because everyone was aware what is the current situation. They had a chance to quickly react if something was turning red, and even more and more teams try to bring up their monitoring to have better visualization of their performance. And it is very important that we not only collect information, but also need to visualize it. We need to make it accessible to the entire team. And in the ideal world, we need to make sure that there is only one data silos with the entire performance monitoring information. And all the teams, starting from developers, testers, and also operational guys, have access to monitoring information. And you charted it in the very prominent places so that the entire team is aware what is going on with your current performance KPIs. The last topic is about feedback loops. So whenever we identify performance issues on production or on development stages or even on test stages, we need to share this information with developers and with the owners of those applications, so they had chance to improve the application. And it's completely not about the blaming game. It's simply about sharing experience, providing a helping hand so that response teams can improve their application. We see many cases where developers are too busy implementing the next big feature, and operational teams are tied with solving all workaround to keep their application running. So don't fall into this trap where your team needs to do all the time troubleshooting. From my perspective, much better solution will be that from time to time, they sit together, they meet with the operational team and testing team and the development team to talk about ongoing issues and share knowledge how to improve these issues. Okay, so let's connect the dots. From our perspective, the high-performance core banking is absolutely doable simply by integrating continuous performance feedback, continuous performance improvement by focusing on automation, meaning performance quality gates and automate quality gates checks, and last but not least, also using the intelligence. There is a lot of AI-powered solutions out there. You can use them for tuning in a highly automated fashion, and you will also free up time of your developers, and they can keep focus on implementing new features instead of troubleshooting and fixing all performance issues. Performetriks is performance engineering service provider in the financial service industry. In one of our projects, we have supported a multi-layer core banking project, and we would like to share key points from the performance engineering perspective. Based on our experience, number one is analysis phase. You need to make sure that you have checked involved business processes. You need to understand performance requirements, meaning transaction volume, response times, throughput of the existing system. You need to find out about integrated satellite systems, what systems are communicating with your old core banking system, and also from infrastructure point of view, you need to understand what is your current setup, what is the new setup, can you reuse some of the servers, or for example, you need completely new environment. The second phase is usually implementation of the new core banking system. In our project, we started up by setting up the base stack that consists more or less the basic functionality of the core banking. And main idea behind this base stack was to create early quality feedback. The base stack was implemented in the few weeks, and we had a chance to perform performance testing on this base stack. So we shifted left using the base stack to create some early performance feedback, which is also very beneficial for capacity requirement planning, because then you can simulate expected load early in your development lifecycle. You can do meaningful performance requirement or performance capacity planning, and you can tell your infrastructure team what kind of hardware, what kind of CPUs or memories needed. Also, we focus about interfaces. What is a communication pattern between new core engine and the surroundings? We focus on end-of-day processing to make sure that at the end of the day, everything runs as expected. We also have implemented full stack monitoring for this base stack, as well as we switched to continuous testing. So basically, we were not testing only, for example, when we have new release, we switched to weekly testing, and even after that we switched to daily testing to make sure that everything is working as planned. The last part is operation. So on operation, we make sure that our online transactions are fine. We also keep focus about end-of-day monitoring. We implemented full stack monitoring. We also implemented the synthetic monitors, and very important part of the operation is alerting. We want to make sure that only the people who need to have the information about, for example, what's going wrong will receive that message. So the configuration of alerting is also very important, and it was very important for this project. The last part is optimization. And because on the implementation on the implementation phase, we done the tremendous job with continuous testing, then I can say that optimization wasn't needed in that project. And when we contacted this bank after a couple of years, they said that they have no completely performance issue in their core banking application. Basically, what are the lessons learned about this core banking replacement project? Number one, shift left. We think this is the key nowadays. You need to start early. You need to get early performance and quality feedback in a highly automated fashion. So testing is no longer something that can be paused and executed in the last minute. As soon as you have the first code written, you should start having a highly automated performance testing and non-functional testing in place. Number two, we think that base stack approach was a very good success because we had a chance to have our infrastructure planning, the early performance testing on this base stack. It was like building a house on the very strong concrete foundation to make sure that you can build a very powerful and reliable core banking system on top of it. Number three, we believe the monitoring first was crucial for this project because this gave developers a fantastic opportunity to see what's going on their application. We have integration APM, application performance monitoring to give them full-time insights. So even on the development stages, they know exactly each and every stack trace, and this monitoring solution basically improved entire quality feedback and entire development process dramatically. And number 4 is, of course, load and performance testing, and even reliability testing was essential for avoiding performance glitches when going to production, or even performance issues later on when more users, more data volumes is flying into this core banking system. After all, we think that it was a big success story, so full stack monitoring and continuous testing is highly recommended for such a core banking replacement project. We, Performetriks, are happy to support your company in performance engineering projects, and please contact us if you need assistance in this area. And that's all from me. It was my pleasure to present the Performetriks engineering concepts. I wish you success in your current project, and I hope we will have opportunity to work together. And as I mentioned before, please don't hesitate to contact us. We are here to help. I wish you all a great day.